Welcome to this explainer. Today, we're diving into something absolutely wild. We're going to unpack this brilliant, home-brewed AI automation setup that basically acts as your own personal, invisible intern. It's called the Exocore system, and honestly, it's a total masterclass in taking everyday, regular devices and making them do some truly extraordinary things. Let's get right into it.
So, what if your devices could complete your to-do list autonomously? Imagine this. You wake up, grab your coffee, realize you need to get something done, and just shoot off a quick task from your phone. And then, you just walk away. While you're commuting or running errands, your home computer is doing all the heavy lifting. We're talking autonomously writing code, planning schedules, doing deep dive research, without you clicking a single extra button. Sounds kind of like sci-fi, right? Well, that's exactly what this system pulls off. To really wrap our heads around how this works in practice, we're going to trace the exact chronological journey of a single task through this Exocore system. Basically, think of it as a bridge. It takes your raw human intent, your everyday chores or ideas, and seamlessly hands them off to a machine for autonomous execution. And the crazy part? It does this using a highly orchestrated chain of older, everyday devices.
Okay, let's start at the beginning, with this super relatable interface. Instead of booting up some complex programming environment, you literally just send a text to a Telegram bot named Task Handler. You type a quick command, like add task 6, and boom, the bot instantly detects it and asks you to categorize it. Is it research, coding, content generation? It's literally as easy as texting a buddy.
Now here's where it gets super interesting. That quick text immediately populates this really clean, live dashboard. Check out these tasks. Everything from a morning workout scheduled at 7 a.m., to a complex review Quen code architecture, right down to plan weekend trip. But look at that yellow status text on the right. See where it says pending agent? That right there is the exact moment your human input is just hanging out, waiting for the machine to wake up and take the wheel.
That little status shift is absolutely crucial. It perfectly captures the handoff from human intent to machine action. You don't have to write scripts on your phone, you're not logging into some remote server, you just text what you want, the system updates its internal source of truth and queues up that pending agent status. Basically, your job is done, and the digital factory's job is just kicking off.
Before we peel back the layers and look at the actual hardware wiring this whole thing together, let's look at the 4 simple steps every single command goes through. Step 1, task creation, which we just saw. Step 2, AI commentary, where the system actually enriches the task with more context. Step 3, execution, where the real work happens. And finally, Step 4, archive, keeping everything nicely sorted and out of the way.
Zooming out for a macroscopic view, you can actually trace this flow. Moving from left to right, the intake node, which happens to be a Samsung phone, catches your Telegram message, sorts out all the metadata, and then pushes it across to the human-facing execution layer. That's a Dell laptop where the actual work gets hammered out before the finished product is neatly filed away into the archive storage area.
But to power this incredibly smooth pipeline, the system leans on a massive arsenal of AI tools. Look at how it scales up from just a few core apps into this giant, robust suite of integrations. We are talking about ChatGPT, Claude, Microsoft Copilot, DeepSeek, Gemini, Perplexity, and NotebookLM, all living and breathing on this one central hub.
So the big takeaway here is that this setup isn't relying on just one single AI brain. No, it taps into what's basically an entire API galaxy. By leveraging the unique strengths of all these heavy hitters, say using Claude for complex coding, Perplexity for deep research, or running local models like Alamaya and Quen for totally private workflows, the system dynamically picks the absolute best mind for the specific job you just texted it.
All right, let's get into the weeds. This is the intensely detailed Exocore-26 version 4.0 schematic. I know, it looks like a giant puzzle, but it's the actual machine room of our digital factory. It breaks down logically into 3 distinct hardware zones. You've got the pager on the far left, the factory hub right in the middle, and the execution layer over on the right. Let's break down exactly what each of these devices is actually doing.
The whole intake process starts with what the creator playfully calls the pager. This is literally an ultra-low-power TCL phone. Its one and only job is remote command and control. Because it sips batteries so slowly, you can take it literally anywhere, shoot off your production inputs via Telegram, and even send human override commands if a task gets hung out.
Next up, that signal jumps from your TCL pager and hits the factory hub. Now, this is a Samsung A05 smartphone, but it's definitely not being used to scroll social media. It just sits on a desk acting as the ultimate orchestrator.
It's the true brains of the operation, chewing on your raw intent before handing it off down the line. Behind the scenes, this little Samsung phone is doing some serious heavy lifting. It uses Cloudflare to create a NAT bridge which lets it securely catch webhooks from the outside world. It's running a Termux orchestrator to route the logic out to that API galaxy we just talked about. It uses an Obsidian Vault as its own local database to track logistics. Man, it even has a built-in circuit breaker that fires off an alert if a task fails and has to retry more than 3 times.
Okay, so once the Samsung Hub has thought through your request, it packages the whole command into a super simplified, easy-to-read JSON task contract. This contract has the destination, the type of task, and your raw intent. Then it ships it over to the muscle of the operation, the execution layer. And amazingly enough, this muscle is just a standard Dell Inspiron 15 laptop rocking a mere 4 gigs of RAM.
Over in the execution layer, the Dell Workstation Listener is just sitting there, actively waiting to catch that JSON contract over the local network. The second it grabs it, it hands the package straight to the task interpreter. This is the exact spot where the translation from a human idea into machine action really solidifies.
And guys, this is where the magic literally happens. The task interpreter converts your intent into command line interface instructions. Then, a tool called the FreeBuff CLI steps up and takes over as an autonomous coding agent. It reads through local knowledge files, scans the working directory, and autonomously generates raw Python or Bash scripts to finish your chore. It is writing and running code completely on its own, all based on that one little text message you sent hours ago. Finally, once the Dell finishes running those scripts, it cleans up all the logs and sends out a clean callback. It updates its completion status, marking the task as done, blocked, or needs revision, and neatly packs up the finished code, data, or research right into the archive storage area. Then, it just sits back and waits patiently for your next text.
So as you digest how this incredibly structured system links a simple text message all the way through to autonomous code execution, I want to leave you with a thought. If this is what someone can build right now, at home, using an old Samsung phone and a 4GB Dell laptop to construct a personal digital factory, ask yourself, how could you apply this kind of autonomous architecture to your own daily grind? What will your productivity actually look like in 5 years? Thanks for hanging out with me on this explainer. I really hope it sparks some wild ideas for your own workflows.